The next math topic we're going to look at is the notion of divisibility of integers. So first thing we're going to do is define divisibility in terms of division. Then we're going to actually give an alternative definition in terms of multiplication. And finally, we're going to apply divisibility to factoring. So as we've seen, when we do a division problem, sometimes we get a remainder and sometimes we don't. This is going to be for those times where we don't get a remainder. So for instance, if we divide 6 by 2, we get a quotient of 3 with a remainder of 0. Similarly, with 18 divided by 9, we get a quotient of 2 with also a remainder of 0. So in these cases, we say that a number a divides another number b, and we write that as a divides into b, right? If b over a is an integer. Now this is a little bit confusing because when we say it, a divides into b, the a comes first, but the division problem that we're thinking about is in the opposite order. We're looking at b divided by a. So we actually have a couple ways of saying this same thing. So if these are preferable to you, these are more clear to you, you should feel free to use them. We could say that a is a factor of b. That's the same as saying that a divides b. We could also say that b is divisible by a. That one's kind of nice because it puts the b and a in the same order when you say it as you do when you do the division problem. Now, if you think back to our quotient remainder days, which weren't too long ago, with divisibility, we're looking at the problem b divided by a, and that was exactly the problem that type of problem we were looking at when we were doing quotients and remainders. We had something like b is equal to aq plus r. So when we're talking about a dividing evenly into b, what we're saying is we have a remainder of 0, which means that b is equal to aq. If the r is 0, there's no r, so we just get b equal to aq. So this gives us another way of defining what it means for one number to divide another. We say that a divides b if there is some integer q, such that b is equal to a times q. And notice here that this is a definition that is purely in terms of multiplication, not division. But we, of course, know from our experience with the quotient remainder theorem that b equals aq is really a division problem in disguise. So if we're looking at an example, if we want to know if 3 divides evenly into 18, then what we would do is take 18 divided by 3. We get 6, which is an integer, which means that 3 divides evenly into 18. But we could also say that 3 times 6 is equal to 18, right? That's a multiplication problem, and that tells us the exact same thing, that 3 divides evenly into 18. So I want to talk a little bit about factoring because that's going to be something that's really important to us much later on when we start talking about more complicated encryption systems. Divisibility helps us break down numbers into factors. The definition itself breaks it into 2 factors. So again, what we had before was the fact that 3 divides evenly into 18. It breaks 18 down into the multiplication of 2 numbers, in this case 6 times 3. But we could break this down even farther if we wanted to. For instance, for 18, we can break this down into 2 times 2 times 3. The question is, what happens when we take an integer and we break down the factor as much as we possibly can? When we start considering these things, one of the natural things that comes out of this, and this will be in the next video, is the notion of prime numbers. And in fact, if you look at that 18 is equal to 2 times 2 times 3, that is what we would call the prime factorization of the number 18. But we'll get into that in a little bit. Anyway, now you're ready to look at divisibility of integers on the PDF included with this video.